MDM4U 2.1 data analysis with graphs. Raw data is unprocessed information collected for a study. It is the data itself, no calculation, no interpretation. Statistics are the gathering, organization, analysis, and presentation of numerical information. A variable is a quantity being measured. So two types of numerical data, meaning that it's quantifiable and that it can be put in order from least to greatest. Discrete data, it's countable. Values are separate. An example would be number of students in a class and number of trials. We have been dealing with discrete sample spaces in our counting techniques unit, where there is a whole separate value, such as 10 ways to do something or 11 ways to do something, nothing in between. But continuous data is different. It is uncountable. A value exists between any two values within a given range. Height, weight, time, and length are examples of this. An example using height is 180 and 181 centimeters. These are two heights that exist, and in between those two values, there's another value. You could take the midpoint, for example, and it's not like you instantaneously change from 180 centimeters to 181. Every single value between those two is expressed when you grow. So there's actually an infinite number of heights between 180 and 181 centimeters. So next, categorical data. Labels are assigned to the outcome instead of numerical data. Example, color, type, and country. Oftentimes these can't be put in order from least to greatest. They are names, and we have to present them differently using graphs. So, frequency tables. Frequency refers to how often something occurs. A tally is used to count observations, and the frequency is how often it occurs. So, in this example, this looks like rolling the sum of two die, and the outcomes are expressed here in a tally where we write a tick every time the outcome occurs, and then to make it easy to count, draw a line in between. This represents 5, this represents 4. So on every fifth, draw a line in between to group. Easy to count. As we expect, the center is more frequent. Cumulative frequency is a running total of the frequency of a variable beginning with the smallest value. So this is the same data, but look at 4, and then it goes to 6 because 4 plus 2 is 6. 6 plus 3 is 9. 9 plus 9 is 18, and so on. This is an ongoing total or a running total. Bar graphs and histograms. Now these look very similar on the surface, but we'll distinguish between them. Exact values or categories are shown on the x-axis. So we have categorical data here. Notice that they are separated, their bars. A histogram, values in a set can be grouped into intervals to better display the distribution of data. So we can see here that this is a continuous variable. Travel time. If you were to picture the time that it takes each student to travel to school, it can get very precise, to the second, to the millisecond, to the nanosecond, and the likelihood of two people actually taking the exact same amount of time is very unlikely. But what we can do is group data into intervals. That is the key characteristic of a histogram. Notice that it's grouped in intervals of 5. And this can help us gain a better understanding of the distribution of the data, how likely each outcome is to occur. Lastly, relative frequency. Frequency is expressed as a percent out of the total. So I like to think of it as relative to the whole. What percentage is it relative to the whole? So we take our part of that, we're wondering how frequent is it, divided by the total, that's the fraction, times 100%. So keep the percentage sign just to be able to express it as a percentage. This is common with circle graphs, and That helps you compare the different components to see how much it has compared to others.